So the question number 6 here, a block of mass m is placed on the smooth inyl wedge, that is ABC, of inclination of theta degree as shown in the figure. So the wedge is given and the acceleration a towards the right. The relation between a and 0 from a and theta, that is the angle, from the block to remain stationary on the wedge is, we have to find this, that is the option that you can is 1 2 3 here. So we have to find the relation between the angle that the acceleration that we have and the angle that we have to make for the block remain stationary on the wedge, that is the wedge here, that is AB. Okay, let's take it, this is the wedge here, so we have to find out the here the A, that is the point here. Suppose this is the point that the acceleration that we have from this angle to the theta. So let's take this is a box here. So the gravity will pull the mass of this, let's suppose this the mass will be m and the gravity will be mg, and the acceleration that we have put is ma, and the towards angle is made by n sine theta, and the upward will be n cos theta, and n will be the north direction here, and the theta that is made by the triangle is also equal to the degree between the mg and this, and also equal to this theta here. So in non-initial frame, n sine theta is equal to ma, like this n sine theta is equal to ma because these are opposite but equal, and n cos theta is equal to mg, that is that take is as one and second equation. Now if we divide both equation, the n will be n cancel out, and we will be left by tan theta, which is equal to a by g. So a is equal to g tan theta. So the answer is fourth option, that is a is equal to g tan theta.